So, hi everyone, and again, good morning, good afternoon, good evening, wherever you are. I welcome all the participants who are listening us today live here, and those who will be listening us on the YouTube later on. So, today is the third day of a three-day webinar series on the topic of analog space mission. And today it won't be the traditional presentation, but we'll be talking to Eleanor a lot and trying to get answers from her and some insights on how we all can proceed and take analog as our career option. So let's begin with today's day. So hi Eleanor.
Hi everyone, welcome to third day and thank you for making it so far.
Yeah, so I'll not waste any time and directly jump to our very first question. So on the very first day, you told us about how you came across AstroCapsule through the Facebook page and you applied for it and you got selected as the crew commander. So what advice or tips would you like to give to someone who is aspiring to be a crew commander for missions, maybe analog or real missions as well?
So basically to become a crew commander, it's not necessarily always up to you. Okay, so there's several things. Basically, when you form an analog astronaut crew or even an astronaut crew, you have to look at how people are between each other. So when we were selected as a crew, we were not selected only as individuals, but you are selected as a balance of personalities. Okay, so for example, I'm the kind of person who doesn't mind leadership, but also likes to lead. Okay. And that's something that's very important as astronauts. You need a bit of this both. But if you compare me to the other members of the crew, I was more of a leader than others. Okay. And also, it was about being very organized, being very communicative, being very empathetic. So I was able to see when my crew was unwell, and I was able to come and talk to them and also understand how each of them basically works. Some other people could have been leaders, but you could see that they were a bit less empathetic. And in my situation, actually, I didn't become crew commander from the start. It was after a few trainings together when everybody got to see how we worked as a team. I was elected by the team, and it was approved by the Mission Control Center and the rest of AstroCapsule. So there's only so much you can do. You can, improve your communication skills, improve your empathy, like really try to understand what people think, where they might need your help, where they need to be micromanaged or not, So you can also do kind of a bit of psychology. So for me, I was reading a book that I really love, that it's just called Surrounded by Idiots. And it was recommended by an astronaut that was selected by NASA like 2 years ago. And she was giving a talk. She was like, well, this book was amazing. And not only does it have an amazing cover because you're in the airport and it's written surrounded by idiots and people are like, wait, what? But it actually talks how people are different, what kind of triggers they have, what kind of team you have, and how can you create the optimal team depending on some personality trait. And this really helped me in understanding each of my crews and knowing how to communicate with them. So this is something you can do. But then if you end up in a team and you are less naturally a leader and there's a natural leader, they will become the commander, okay? Unless they have a massive default trait like they're super disorganized or something. But this they can also improve. So actually one of my astronauts, he's like quite disorganized, but he's absolutely passionate and he works really, really well. And you could see in the 2 years that we worked together how he improved. And for at some point we had a crisis in the base that we didn't have any electricity going on. And he did all the mapping up, and then he was talking to the crew and was like, yeah, we have this problem. So you guys, you do this, and this. And I went to him, I was like, dude, I'm so proud of you. Like, remember a year and a half ago, you barely used to talk to us because you had problems a bit with your English and you were not really super sure of yourself. And now you are in the mission and you took leadership and you told us what we had to do. And this is exactly what you want. So you can progress, but still, there's limits. I hope that answers your question.
Yes, it definitely does. And you've highlighted so many qualities. Like people don't, when people are thinking of jumping into space or space industry, they are like people should be masters in just physics, in maths, and science. They do not like value, like the very important word you use, empathy or working in team, leadership. So I think that's the key takeaway from this answer, that we need to take care of all the qualities when we are, trying to focus on becoming the crew commander. So yeah, very good. I'm really satisfied with that answer.
Uh, yeah, it's true that as astronauts, you have to be good at everything. That's the thing. Is that or you have to be able to improve in everything. You don't need to be born knowing 6 languages and being good at sports, but you need to be able to train yourself to have a certain level. And if you have a Nobel Prize, but you're not empathetic, or you hate teamwork, or I don't you have a bad health, you can't become an astronaut. That's the thing. It's like there's only so much you can do, even if you're a genius in some respects. You have to be good at everything.
True. So now, as we are talking about the mission itself, as we know, like every mission has certain objectives to fulfill. So, what was the mission objective of Astropolis 1, and how did the crew work together to, attend accomplish them?
So we have several goals, and compared to other analog space mission, the main goal was to show that we could be a functional space mission made by students and led by students. So as mentioned on Friday, we were all students, so we all have to reconcile exams and studies and being still very young. So this actually had a massive impact. Like obviously young people have massive capabilities, but sometimes you like self-confidence or you like experience, and yet we proved that we could do one. And by being satisfying, I mean that we did the whole training of the astronauts, we prepared the logistics, we went from day 1 to day 8 without big problem. Like we didn't have to cancel the mission, we didn't have to abort anything during the mission, nobody got hurt, nobody, like there was no damage, there was no scandal. So we managed to do all the experiments we had to do to keep everyone safe, to keep everyone happy, to do everything almost on time, or we're flexible enough. So in these regards, we were, we achieved everything we wanted. Obviously, there were some like little problems that we could not achieve some goals. So for example, you have experiments, okay? And because we were student-led, most of those experiments were part of Bayshore Master's project, but also some of them were biological like experiments. And for this, you actually need ethical approval. And this ethical approval sometimes was too late, and so we couldn't perform them during the mission, which was good because we were really packed. So actually, if we had had those extra experiments, probably we would have been overloaded. So yeah, it's difficult to define like 100% the mission objective because there's so many objectives, but mainly that we managed to perform the whole mission, that we didn't have a major crisis, and the mission was safe and a real success, basically.
That's nice to hear that you could accomplish all of the objectives that were assigned for the mission. So, while talking, you mentioned some of the experiments, and also you mentioned that the mission was for 8 days,
Mm-hmm.
right? So,
Yeah.
generally, a mission has these three: pre-flight, in-flight, and post-flight conditions. So, did you guys also train for these three particular periods, or it was just a training before the 8-day mission and then just the end of it?
So basically, we had training for over a year and a half, both for the mission, but also to get to know each other. And then before the mission, we all came like before on the base. So basically, we were renting a school, which was in the mountains. So because the mission was like up in the pass in the mountains, So we were a bit lower in the valley. And we were all sleeping there and cooking for each other and getting to know each other and setting up stuff and doing some trainings. And then basically they told us, well, the liftoff will be you take this bus, this van, and then you have about, I think it was 6 minutes drive all the way up. And then you get there. And then once we give you the go, you open the airlock, you close the airlock, and there you give your message. So with my crew, we also like prepared like a little message, on what we would say, because it's technically our lunar base. So we were thinking, okay, we need to say something. And, but yeah, there wasn't really pre-flight or post-flight. Like for example, we didn't do any medical examination after the flight. not only because there were so many things to do, but also timing wise. So you have to understand, some people had just finished their exams right before the mission and were starting internships right after. Okay. Or we landed at 6 p.m. We had right away interviews. We had a post mission debrief. And most of us, like, I was on the phone call with somebody from the radio, then somebody else from the TV comes to you. All of the astronauts are like, taken apart and like talked to. So it's very, very busy. Then we had the apero, so like just dinner with the people who organized and sponsored us. And then it's already like 10:30 in the evening. And the next day you have 2 days to unpack everything. So from 6:30 in the morning, you have to go back up and undo everything, which is not something you would do in a normal mission. Okay, so this is where you break a bit apart. But it also shows that it's not because you were an astronaut in the base that you're not going to do anything. Nope, you have to be there. You have to help because, again, you are students. Okay, you can't just pay someone to do this for you. You have to do the job yourself. So in this regard, it's a bit different. Like, we didn't have as much a pre-flight and post-flight event. But we had celebrations, so that was the best way.
That counts.
Exactly, yeah.
Nice. And talking about the experiments, I was listening to this podcast. Like there's this podcast where we can go and listen to all your experiences throughout each day. So
Nice. Cool,
yes.
university did it.
So I came across the experiment that you guys were working on, and I think it was related to bioplastic or something. Correct me if I'm not right. Yeah. So could you please explain a bit more, like what the experiment was and what results you were trying to get from the experiment?
So basically, the bioplastic experiment was about creating a kind of a tape, like, for example, a compression or things like this in case you have injuries, made only from bio material. Okay, so from stuff that you could find in the base, so you could grow your own, plants or whatever, and then use it in the biomaterial using stuff that you would find in the base. We had, like, for example, vinegar, or we had vegetable oil, we had cucumber, like dried cucumber, and I think it was maizena, something like this. So, like, the powder you use to thicken, and you just had to create this like batch, and you had to put different contents of each of the material, and then you had to take pictures and say, well, you can see that it dries after this much time, it's quite elastic, can we wear it while wearing the spacesuit or not, like, is it useful? And for example, we had much higher humidity than planned, like because we had this problem with diffusers, we didn't have as much electricity as we wanted, so we couldn't use the heaters as much as we wanted. So the humidity and the heat were not the normal lab conditions, okay? And obviously in laboratory condition, usually it's 20 degrees Celsius and say 65% humidity. There we had 89% humidity. So the bioplastics were not drying as quickly as they would. So I got really annoyed at mine, and I was like, okay, I've got 15 minutes. Can I redo one? And then you take pictures every day, you weigh it. So you try to see how much it dries, or if it's taking some of the humidity just by the weight change. You look at the aspect, and then you just play with it. So I took some bits and I was like doing like this to see if it was quite soft. Obviously it's not like high material testing, that we did not do tensile testing or compression testing on it. It was more kind of visual aspect. But yeah, no, it was quite interesting. It was good. It's like the day that you're done with them, you can throw them on the waste, or you can burn them if you were to be in a close-up, because it's made from vegetables, so it's not pollutant. It's not like when you're done with tape you have to throw it in the bin, and there's glues and there's this plastic and this paper, like this different material that are not necessarily always recyclable. So it was quite fun and really easy to do. It was more like almost cooking than experiments.
Nice. And I think if people are listening today, this could be a potential research topic for them if they're interested in material science.
Mhm.
So yeah, that's
Yeah.
very, very interesting. And again, in the podcast, there was mention of this lunar earthquake simulation that you guys performed. So
Yes.
I am personally very interested to know, like, how did you simulate a lunar earthquake and how did you guys perform that entire task?
So this is the video I wanted to show you, but which is confidential. So I'm not allowed to. But I can explain what the experiment is. So basically, there could be some moonquakes or Marsquake, possibly not very high, but it could happen. And if you are on Earth, obviously an earthquake is already extremely dangerous. But when you are in space and there's an earthquake and it might damage the structural integrity of your base, there's a danger of air escaping, and then you have depressurization, and then you will die. Or maybe you will get high radiation if there's a massive block leaving. So there's lots of consequences. So they told us, okay, we're gonna do basically this mass alert system, and they they tell us, well, you have either impact in 5 minutes, I think 3 minutes, or 1 minute, okay? And depending on the level of the alert system, so if it was blue, if it was orange, or if it was red, we had this much time to escape to the airlock, and we had a different procedure. So, for example, the lowest alert level, they told us, okay, you go down to the science experiment, you turn off all the experiments, you cover them with a blanket to, avoid having stones falling on them or damaging the equipment. You take a computer with you, you take a radio with you, you take the first aid kit, you do a head count of everyone, and then, you wait in the airlock until you get the go from the Mission Control Center that everything is fine, okay? The orange one, it was like, okay, you turn off the appliances, but you don't have time to go to the science experiment. First aid kit, computer, radio, first head count, and airlock. And the red one was, okay, first aid kit, computer, radio, airlock, head count, that's it, okay? But we didn't know when they would do it, okay? So we had trained for it, but not in the base. We had trained in another room a month before, so we had to simulate what was what. And yeah, so basically we didn't know when it would be. And every morning we would wake up at 6:30 usually, and there would be kind of some alarm or like a wake up music, and we had these tunnels, and there you had the computer who made the music. There were beds, and my bed was one of the furthest away, so I couldn't hear that well. And one morning I hear red alert, red alert. And I was tired, so I took time, and then I realized, oh, this is not alarm clock. This is a moonquake alert system. Okay, we need to go. So I woke up the whole time. I was like, moonquake, get to the airlock. You get the first aid kit. I'm gonna go and turn this off and take a computer. Then we went back to the airlock, and I was wearing flip-flops. I didn't think of wearing the normal shoes, so I almost fell. So I told them, okay, bug report. The next time I need to not wear flip-flops because it's dangerous. But I didn't think about it before, Got to the airlock. We put everyone in one of the cubicles, us and the others. Then we got the go from the Mission Control Center. And basically what we did is the base engineer and I, we put on our spacesuit, because obviously if you were to have a depressurization, you will think, well, the airlock is probably fine, but the rest of the base will probably be compromised. And also it's good to have a helmet in case you have some rocks falling. So we get a protocol on the computer, and once the Mission Control Center tells us, okay, no more earthquake, it's stable, you are go to exit. We exited the base, and we tell the rest of the crew, you do a medical checkup of the rest, and you send us any reports if anything happens, okay, and then we will forward it to base to the MCC. And we went around the base, and I had the camera, and the base engineer was taking notes. And basically you look for cracks, and you see if electrical appliances are working, communication is working, anything that could be disturbed. So obviously we didn't have a real earthquake, moonquake, but we were simulating. And what was really funny is I only realized once we were in the airlock back that it was 2:37 in the morning. They made us do the exercise at 2:30 in the morning, which is why I didn't hear the alarm right away, and I took time. So yeah, we were a bit slow on the thing. And then we redid the experiment the day after, but they had warned us. And actually we had to adapt it because I was still doing another experiment with the base engineer, and we needed to finish this. So they told us, okay, well, now it's going to be the rest of the crew who does it, and you guys pretend there's no moonquake. But I think it's a very important exercise. And I think structurally, even if you go on an abandoned base, the protocols that we had to assess the level of damage and if it was safe for us to come back is something that should be used automatically when you re-enter a base, because you never know if there's going to be even an electrical fire or hazard or fire hazards or, structural integrity problems, communication problems. So it was a cool experience, and we also could give them a report saying, well, we should have put the spacesuit and the airlock and not in front. We didn't have much space, so it's not as if we had that much, of a choice. But for future missions, we can tell them, well, you need to improve this if you do the same experiment. And yeah, we realized that we can wake up at 2:30 in the morning. It took us 1 hour to complete the thing, and then I went to do another debrief. And then we had to get up, but they gave us like 15 minutes more to sleep in the morning after this. But it was good. It was a lovely experience, and luckily in the evening it was our night off, so we could finish a bit earlier, and everybody just chilled and
Good
then went
rest.
to bed early. Yeah.
Wow, that's really amazing. Like I'm trying to imagine myself in this situation. How would I react if someone tries to wake me up in the middle of, when I'm sleeping? That would be a problem for
Well,
me because
if you have me yelling at you, you will wake up. Like the problem was I took time to wake up, and then like the others were a bit like me, a bit sleepy, and then I was like, red alert, get up, we need to evacuate. And then it's like, okay, yeah, okay, we need to do this.
uh, amazing, amazing. And while you're talking, like you mentioned, you were in the tunnel, right? So this
Yeah.
takes me to the idea, like it is an hypothesis, and we think it could be a potential habitat for us, that is the lava tubes on Moon and Mars. So what do you think about that? Could that be the possible option for us?
You mean to go to Moon and Mars? Yeah, yeah. So those lava tubes, the reason we test them is because we think they are the solution for at least some of the problem. I'm just thinking right now. So we had several interviews during the mission, and you could have a look. I mean, it's in French, so you guys don't have to, look at it. But I can send you the link so you can see how the base looked. Otherwise, I also have a video where you can see the whole base, but again, it's in French. So, like if you are interested, I will send you the link. And I also have prepared the links of other analog space missions so that you guys can, just apply if you're interested or have a look. And yeah, so just let me know.
Yeah, you could, the link you can share it in the chat itself, or you can mail it to us and then we'll forward it to the participants.
Yeah.
Anyway, it works. Yeah. So moving to the next question. In whenever we are doing an emission or performing an emission, there's this exercising criteria astronaut needs to follow. He needs to exercise for a particular hours per day. So during the mission, what was your routine? Like, how did you guys try to keep up with the exercise?
So we had allocated time for the exercise, and we had three types of exercise. We have cardio, strength, and one that was our choice. So, for example, we could do meditation, we could do an extra round of cardio, an extra round of strength. And basically, we had some dedicated exercises to do. We had a rowing machine. We had the stairs. So often, most of us were running up and down the stairs, and it's you're already in the mountains, and it's really really steep. So it was a really cool exercise. We had skipping rope, and we had a webcam, and it was funny because Mission Control Center could see the skipping rope coming closer and closer, and they're like, "Yeah, okay, just so you know, could you tell astronaut Ogalda to stop skipping near the webcam because we're getting really scared." So yeah, we could do all those exercises quite well, and then you could follow the plan, but at some point some of the exercises seemed too redundant, so some astronauts also did their own routine. This is a bit out of procedure, but obviously sports was also one of the moments where you can release some serotonin and dopamine and you feel really really good, so it's sometimes good not to criticize somebody's routine unless they're just sleeping. If they're just sleeping, then you can go and tell them, look, you're not doing the right exercise. In space, you would have way less flexibility regarding this, because obviously it would have consequences on your cardiovascular system. In our case, we knew it was only 8 days and we're on Earth, so we still have the gravity, so we're still working against this gravity, and we're probably more active than we usually are, because we were running up and down all the time doing, we had 2 floors going up and down that were really, really steep, so it kept us really fit.
Yeah, like following exercise especially is like integral part of astronaut life, I would say, because they have to maintain it and do it right. So like exercise, did you guys also have a diet plan as it's given for astronauts when they're on actual mission?
So we didn't have a diet plan in the well. That we didn't have to measure what we ate per individual. So it wasn't like, oh no, you had like 2 grams of protein extra. We ate what we felt was good, but we had a nutritionist that prepared all the recipes for every meal and every snack. And we had not only to respect it because of the diet itself, but also because of the how's it called, the inventory. So basically every time we ate food, we had to remove it from the inventory so the mission control center knew how much food we had. So in this case, we couldn't be crazy flexible, or if we wanted to change, we needed to get approval from mission control center. But usually we ate and finished whatever we ate. So you have some astronauts that are very tall, some are very small, some eat a lot, some don't. And also, as a commander, I was often looking at if somebody was hungry, I would give them a bit more food. And I wouldn't go hungry per se, but I know I deal well with not eating too much, whereas other people don't. So I felt better to give them a bit of my food to make sure that they were fine enough and could focus than, take food just because I felt like it and felt hungry and a bit greedy. So this is something you have to be really careful not to be greedy, because there's not that much food either. But usually we're doing fine. But lots of us lost weight actually during the mission simply because it was way colder than planned, and the calories were not adapted for this cold. Actually, it was not something we had foreseen. So yeah. But you don't have a diet per se, but we still got a free diet.
Yeah, because like I would say, especially for Indians, if we don't have our stomach full, we can't concentrate and work.
It
So yeah,
happens to a
diet
lot of
plays
people,
a
yeah.
yeah, yes. So diet plays a very important role, and that's very true. So moving on, isolation is one of the other obstacles, I would say, of the mission. So your personal experience dealing with isolation, how was it? Like how you felt being isolated and just with the uh, crew members, like just you guys, no contact with any other people around. So how was your experience dealing with isolation?
I didn't feel isolated at all. Well, I mean, I had 9 quarantines before I had the mission, so I was used to doing a real isolation in my room alone. But I mean, doing the mission, you were 5 other people, non-stop. You sleep next to each other, you eat together, you do experiments together, you do sports together. I mean, the only time you're alone is when you're on the toilet, and usually because there's 6 people, after 2 minutes they knock on the door, so you're never actually alone that much. And also, don't forget, even if we don't necessarily have much contact with our families, or only some very small times, you actually in constant communication with mission control center. Okay. So this also, it sends you a link back to Earth. So I never felt isolated. And you could think, well, you're 1.5K away from the surface. So if there's a problem, you're quite a
Yeah.
long distance and you're 450 meters on the ground. But I had maybe 10 seconds at the very, very big beginning when I visited for the first time the tunnel, where I was a bit, oh, I'm down in mountain. And the rest of the time it was so beautiful. It was such a wonderful mission. And you are in mission mode. You don't think I'm away from people. No, you literally have a massive crew taking care of you on Earth. You have people from the base, the people who did the setup, who are also always helpful and they can help us. And you're with your crew. So it's something that if you do a Denmark space mission, maybe you would feel more isolated. For example, the thing that we talked about with the communication delay, we have 24 minutes. There, I think you would already feel way more isolated, okay? Because you take a bit of time.
Yeah.
But for us, we didn't have this delay, so it was okay. And and we had each other, and then when your crew, it's like it's your roommates, they're your family, they're your friends, they are a pain sometimes, but they there, if you were maybe 2 people or 3 people, like a smaller crew, it would probably already also impact this feeling. So no, I never felt isolated. I felt really amazing. It was wonderful.
That's very new to learn that you did not feel isolated throughout the mission. That's nice. So as we are talking about isolation, were there any recreational activities that you guys did during the mission to keep yourself sane and entertained during the mission?
So I was quite busy because I liked looking for stuff to fix in the base. So as commander, I enjoyed the mission so much. I wanted to make sure everything was working. So I wasn't using my free time that much. I was just looking at stuff. But my crewmates, one took his bass and the other one took his guitar. So two people played the guitar and one took to play the bass, and they were singing together, playing together. Sometimes, we were just having a time where we discussed and played games. Sometimes I think one of them was playing chess, for example, and yeah, we had maybe 3 family times of half an hour allowed, or twice, something like this. So we also had this, but in the end, we didn't have that much free time, So a few of them also tried to rest because they were quite exhausted by the constant working, and it goes by really quickly. You don't have time to do too many activities.
Okay, so I was expecting a bit more that you guys might have done, but as you're saying that we don't have much of the time because we are almost engaged with the mission objective, so maybe that might be the reason. And so I have last question regarding the mission, and then we'll talk about you in general and space industry in general. So, what's your opinion, or what do you think? Like doing analogs, how will it help us in our future space exploration?
It's not how it will, how it helps. So it already really helps. Every time, even NASA and ESA have their own analog space missions, like, or their own training, and it helps in the way that you test the equipment, you test the robots, you test the habitats, you test the people. For example, even the first time we sent somebody to space, we had no idea what would happen. We didn't know if they could breathe, if they could drink, if they could eat. And now obviously we know that, but we also don't know, like, how will the first human that we send to Mars feel when they see that Earth is so far away? Because, for example, from the moon, you could see the Earth, okay? You see this big blue thing, it's beautiful and everything. But when you are going to Mars, you see a dot. So psychologically, this is something that we want to try to simulate as close as possible, because we want to see how people react. Because if you go crazy and you start killing anyone, then there's no point spending billions there. We need to find a way to get over this. So psychologically, it's something that is like really, really interesting. And also, like, for example, all the experiments that we did. For example, one experiment that I found really, really interesting was the hydration process. So where you remove perchlorates from Martian soil and you try to make it fit for agriculture. Well, we realized we didn't have the right equipment, where it would take way more time. And then you think, okay, now think about less gravity. You can't use the same system. What happens? Okay, every time you do an analog space mission, you test a system, or you test a person, or you test a plant. Maybe, for example, if your plant can, survive on the ground, then there's high chances they wouldn't mind surviving in a spacecraft where you don't have that much sunlight, right? It's the same thing. Every analog space mission, even if it's not necessarily super protocoled, or it doesn't have all the aspects, is always bringing something to space exploration.
Yeah, very true. And that's why we need to popularize the idea of analog missions and encourage people to participate in it. So ultimately, what we are doing is we are enhancing and improving our future space exploration, right? So,
Exactly, yeah.
yeah. So that's all questions I have regarding the missions. So let's now move to the chat box. Let's see if participants have any particular questions for you. And then I will come back again to my questions, which are in general about
I
space.
have a question. I have a little question. Maybe this year we need to create it international protocol for analog missions with all the team for try to understand that mission is this year. Artemis will go to the moon, so this year is very important. And maybe we need to try to understand two more meetings for try to create it an international standard for analog projects, because around the world they maybe exist two more projects, and this is exponential project for try to understand with the go to the moon and Mars. Maybe we need to can create it international standard for try to understand more better science.
So I think yes and no. This the pros of an international standards would mean that it wouldn't matter which space mission you take part of, you would have a certain level of accuracy, and like it would be probably help more science. But it depends also what is the objective. For example, some people they train astronauts that directly. So NASA, ESA, they train directly astronauts. And others, they train to see, they're training students, like for example, AstroCapsule, they're training students to then work to simulate a real mission. Okay, so this is something else. Okay, they see, okay, how much budget we have, and others they want to just train the science itself. When you do a protocol, you assume that everyone has the same budget and everyone has the same qualifications, which you don't. And what is amazing with space is that you enable everyone to love it. And with the Xano space mission, in a way, it's annoying because when you apply, you don't know how good the level will be, and some cost money, some don't, But at the same time, the fact that they're all different, it also creates this versatility that is very, very much needed still. So I agree with you, but I don't know what impact it would have to have the standardization, because I think it would cut the opportunities for a space mission that would be arising, by not fitting to the standard. So you could always have, space missions who do not fit the standard, but it would have, for example, we're talking on Friday, if India created its own analog space mission, either resort or, program, maybe they would take a year or two to fit a certain standard, because you need to raise sponsors, you need to have maybe the government that backs you up, and that always takes time. If you have a standard and you can't meet it right away, maybe you'd be shunned, and people who would be amazing, they will be like less interested when actually they would really help and contribute.
Eleonore,
Yeah.
I'm sorry for this question. This is a medal for my working with the Chile Navy, and this Friday we have a meeting with the chief commander for start training in the Scorpion class submarine. Okay,
Cool.
for
Congratulations.
we need to talk with you. We need to talk to Richard. We need to talk with other projects around the world, because Atacama plan is very great and very important for study, because the Chilean Navy offers for in July we go to the Antarctic project. Okay, so
Yeah, just send an email. That'd be
we
great.
have
Yeah.
a meeting with the India, with the ISRO, with the Habitat Mart, with the Asclepios. Tatiana Lopez will go to participate in a second mission in Asclepios.
Yeah. Yeah.
And I was read email with she and comment this project. And this is in this meeting we need to announce the permits for have a new meeting with the Chilean Navy for to start the training.
That'd be perfect. Yeah, we can discuss on Friday for this. That'd be lovely then. Yes. Please do send me an email or contact me on LinkedIn. I'll look
Yeah, absolutely. Don't worry. This is a great project, but we need to will go to Antarctic. Okay.
Yes. Let's do this. Fantastic.
Yeah, we need to go to Eden base for the European Association. It's very great important.
Yes. Thank you so much for this. Yeah.
I can help us. Okay. So we need to try to understand how more better working.
Perfect.
Have a good day.
Thank you. You take care.
So moving on to the next question from Adarsh. He says, how do you get the funding for analog space mission?
So basically, the funding we got was often from companies that are local to Switzerland. So we're trying to get people from technological centers. For example, we had Logitech who wanted to sponsor us. So you have, for example, the cameras, the webcams, or the computers. We had lots of university that were partnering us, but sometimes they don't necessarily have the budget. They can just give us either a room or maybe some pencils. So any kind of funding was basically welcome. We were also funded for some vegan cookies. So we were eating vegan for the whole mission, because on the moon, it's very unlikely you have a cow eating, in the fields. So we were also sponsored for nano cookies and planted chicken. And also we had, how's it called? We had another plant that is rich in iron that was spirulina. We were sponsored by spirulina. They did amazing also chocolates for the Mission Control Center. So it was amazing. But also some of them is money. So Huag Space, which is one of the main aerospace companies in Switzerland also like sponsored us. The eSpace, the Swiss Space Center, they all sponsored us. And yeah, sometimes it's just you have to send a massive document. So it's called a sponsorship folder where you explain the objectives, who's working in this, what you're trying to achieve, and how it will, how it could benefit humanity either as a whole or a certain sector, and then what the sponsors would get. So what kind of visibility? For example, if your project doesn't have any media coverage, most sponsors won't be interested. But we are in Switzerland, which is a very small country that really likes space. Not as much as the US, but we still really like space. So if you tell people you have analog astronauts training in Switzerland, the Swiss media, they go mad. They're like, oh my God, this is so cool. And usually they transform the analog astronaut into astronauts. So for us, since the beginning of the mission, we had a really large media coverage in Switzerland because, they were like, we were not all Swiss, but we had Swiss astronauts. It was a Swiss project from one of the biggest Swiss universities, and it was happening in Switzerland, So you have to play kind of this nationality card. And then because we had people we had Sebastian Ugalde, who's from Chile, he's really he's got massive media coverage also in Chile, So because they knew this, then it gave us even more momentum. And this is something you can then use for the sponsorship. And one thing that I have to mention, when I said that we didn't have much free time, one of the reasons we were not just doing experiments or doing, base maintenance or eating or doing sports or sleeping or, having briefing and debrief, you also have communication time. And during this communication time, you have to do help for sponsoring because and the astronauts, we didn't pay anything. We were paid. So we were paid for the food and for everything. Like they paid us by, giving us the whole mission, right? It means that we have to give back. And the way we give back is we are the face of the mission, okay? So we have to explain what it is. So, for example, I had to give tours of the base to people who had financed us. So we also had a crowdfunding. And the people who had given the most, they got a free visit of the base with me. And we also had people who would just join a Zoom chat and we would answer the question live during the mission. We had postcards also to send. So we had to sign some postcards. So yeah, this is the kind of sponsorship you can also give back. And also in our airlock, we had obviously some names of the big companies that financed this. And when you have 6 or 7 different kind of newspapers and medias that are coming and they film this, obviously it's a massive, outlook. And especially if you're a company who's trying to get into space, this is wonderful because it means that, you kind of opening the door. It's not a massive commitment. You don't have to give that much money. Lots of sponsorship, they can easily give thousands of francs. They don't do it, but they can, So a small project for us, 5,000 francs, it's you can buy one spacesuit and a half, okay? It's a lot. And I think the work package for the astronauts, we were about 15,000 francs. So you pay 1/3 of our whole work package. You pay the training, you pay, the food or stuff like this. So it's amazing, right? But for them, it doesn't make a massive difference, but they get this media coverage and this inlet. So this is usually how it will work for an analog space mission. Governments are also usually backing it up, and also universities, because they get to test some experiments in this context, right? So this is how you should kind of go about for an analog space mission usually.
It's really nice to know, and the key takeaway, I would say that the upcoming companies who are trying to establish themselves in the space industry would definitely come forward to sponsor something like that. So they could be the very nice option, right?
Yeah.
So there are 3 questions. I'd like to combine them. Students want to know, what is the role of a biologist, astrobiologist, and a chemist? How can they play a role in a mission?
So basically, it depends on the experiment. It depends on also the space mission. So for example, for us, the experiments we didn't need that much our background. So for example, I'm a materials scientist. We had a physicist, we had an electrical engineer, we had a mechanical engineer, we had an astrophysicist, so we were all different kind of stuff, but we had to do more chemical experiments. But the fact is, when you are astronauts, you're kind of a puppet, so there's somebody who's like pulling the wires, and you do the experiments for somebody, but you follow procedure. Obviously, I was using my material science background to make sure that it was well done, or I would think a bit more than if I was maybe studying physics or mechanical engineering. But I was not allowed to modify the experiment per se, because it's not my experiment. I'm just enabling it, okay? But if you, for some certain analog space mission, I think Lunaris, if I'm correct, you can propose your own experiment. And this then makes a difference if you're a chemist, an astrobiologist, or a biologist, because then you decide what equipment you want and what kind of experiment, and then if it's approved, then you will conduct it. And if you are in obviously in space, or you're trying to simulate some stuff, an astrobiologist, for example, would probably on an extravehicular activity, so when they get out of the base, they would simulate picking some sediments or anything they find to then do the measurements to see if there's any extraterrestrial life, for example, or they would maybe do some biological measurements to see how the environment is affecting things. So this is where you have a difference. It depends on where does the experiment come from. Are you the astronaut choosing the experiment, or is it planned already by the person who's organizing the mission? And this is the only time that I will really tell you, okay, well, this does this and that. And usually regarding what is base maintenance and things like this, well, you all receive the same training, or usually it would be more an engineer who would do the base maintenance rather than either a biologist or a chemist. They wouldn't necessarily have the training or understanding to do this, so they would have to receive anyway extra training to make sure that everybody is on the same page. So yeah, but then a chemist, maybe they would make their own wine, if you the biologist maybe would be more interested in the farming of the plants you would have in the base, and then the chemist would take the fruits and he would make wine, or she would make liquor out of it. So this is maybe the fun experiments you might get out of it. But otherwise it doesn't make a difference.
Yeah, and there's one similar question. He wants to know, what skill set should a student have to have a career or future in aerospace application sector?
Passion. So yeah, I mean, it depends. It depends what you want to do in aerospace. For example, there's massive things you can do in space law. So you don't need to be an engineer. You can be a lawyer, and then you have to understand space. So the biggest skill set is that you have to be flexible and you have to be interested. If tomorrow you agree to go on a 7-day webinar on space law, you can become a space lawyer, But if you want to be repairing machines, you better be an engineer or a technician, So your skill set really depends on what you want to do. There's not just one way to go to space. Okay, you can be a psychologist. You don't need to study medicine. You can just do psychology. Or you could, I don't know, be a linguist, For example, if you work with the SETI Institute, so the Search for Extraterrestrial Life and Intelligence, maybe being a linguist could be useful, because when do you know it's a random signal, and when do you know it's a language, So many things. So being diverse is extremely important, but also when I look at your CV, if I work in the aerospace industry and you apply for me, regardless of the theme, what I will look for on your CV is your motivation, and if you like space. If all I see is, I don't know, you're a ballet dancer and you're a photographer and you're a fireman or something random, or really cool, but nothing with space, then I'm like, well, why would I get you? But if I have somebody who's absolute nerd and who loves everything about space and has maybe done ballet but in space and has been firefighting for analog space missions, then obviously it's way more interesting, because you already have this connection, you already have this passion and this love for space, which is really important because it's a tough environment, So yeah, I hope this answers your question.
There's another similar question. She wants to know, what role does a software engineer play or would play in aerospace sector?
So I think if you were 1960 or 69 when we went to the moon, a software engineer wouldn't have been really, really useful because there was made almost mechanical computers, right? But now, obviously, you have electrification and software for the controls of rockets. So obviously, this is where a software engineer works, is in the rocket, but also all the communication. For example, for us in the base, we had one person who was doing computer science. Well, obviously, they know not only the hardware, but they also know the software. So when something happens, they're usually the first person who will look into it because they have this training and this experience, and usually they're also very interested into this kind of technology. So this is where a software engineer works. But you could also think, oh, you're going to have robots on Mars. You might have, for example, we were supposed to work with the Robot Hub, which is a robot that takes a plant and measures how much water there's in the soil or things like this. These kind of robots also need software, admittedly not very extended software, but they still need some kind of control or some form of coding, which is where we would need a software engineer. So yeah, obviously there's lots of opportunities in that.
Yes, space sector is a very welcoming sector. We welcome everyone.
Yes.
So you can try regardless of your field. So with this, we'll move back to my questions, and this will give our audience some time to, again, if you have any other questions, you can drop them in the chat box and we'll take them again after my questions. So we talked about the mission a lot. So you also founded the conference on human analog space mission. So what was the motivation behind it?
So basically, so 2019, I got recruited as an analog astronaut. Started the training in 2020 in February, and in April 2020, the mission got postponed because of COVID. So I was locked in my room. I was listening to webinar after webinar on space, and there were several analog space missions. I started to get in touch with people and realize, well, there's actually way more than I thought. But what is weird is if you go on Wikipedia, and now it's improved, but 2 years ago, there was barely any mission on there. And you couldn't find any information. You didn't know. You were like, there was maybe 200 crews or 0 crews. I know there's a mission, for example, happening in China that was a year long and made with students, but you can't find many stuff. You find one YouTube video and that's it. And I thought, well, we're all trying to get to space. We're all trying to improve science. We're all trying to improve the habitats. Let's get together, and one of the best ways to do this is to have a conference where you have this one meeting point where we share ideas. A bit what Paolo was saying, when you do a standard, it wasn't necessary for all of us to get to be the same thing, but to compare. So you have AstroCapsule where nobody pays, it's just sponsors. And then you have Possum where you pay $5,000. How can you upscale or downscale? What a difference does it make? Have a workshop, think, okay, we focused on this. How did you improve this? What did you use? Kind of discuss, and not only because we can improve the experiments, but because also we are similar people. We have different backgrounds, but we want the same thing. And it's actually still rare to see people who agree, like us, to spend our holidays in a tin can, to take bits of their muscles and give them to science, or pee in a box, or there's a lot, but it's compared to the rest of humanity, it's still very, very small. And when you find people like this, it gives you so much energy, and it makes you feel happy. And I thought, well, this is the best thing, is that we meet all together. And I got in contact with Charlotte Powell, who was working at Moon Mars, and she founded the Chilice mission, or she's working on it. And she told me, well, actually, I'm doing also a database with all analog space missions, and so they're still in development. But basically, I told her, well, that would be really cool, because then we have those conferences, and then we can put them together. So basically, it's going to happen in 2 months. It's going to be in Cambridge, because I'm based in Cambridge. So I thought, well, people might know London, but Cambridge is very close and it's very beautiful. And I try to keep it as cheap as I can, because the goal is not to make money of it, is to make a community. And I really look forward to seeing people. And we will put everything on YouTube. I wanted to stream it, on the platform, have people interact, but because we're only like 5 people, hosting it, it's like we're a bit limited on what we can do. But the goal is that it would happen every 2 years later, and that every 2 years you can have an space mission getting their brains together and thinking, well, we do things like this. How do you do things? Okay, this is cool. Yeah, oh yeah, maybe I'll come and visit you. Yeah, that sounds like a great idea. And yeah, so yeah, we probably see some tipsy analog astronauts together in Cambridge in April. But it means that we've succeeded if it's the case, because it means that, people got really friendly together and got to meet each other. And we're also doing an afternoon open door on the Sunday. So the mission is from Saturday to Sunday. And the goal is for people from Cambridge to come maybe with their kids, or, obviously Cambridge is very, scientific. So let scientists come in and see maybe props or meet analog astronauts and have posters. So yeah, I look really much forward to it. It'll be stressful, but it's gonna be fine.
But it's a real good initiative, I would say, like bringing people together with similar thoughts. Perfect. And if anyone wants to be a part of it, what's the procedure? There's any procedure that they need to follow, or?
So if you want to help, you can without any problem. If you want to give a talk, you need to be organizing one of the analog space missions. So the problem is, because I'm limited on space, like we had only 18 places, like you have to be really careful. And because I thought, well, we can, for example, invite 9 different space mission and limit the number to about 8 participants, and so that you also don't have 8 people talking on the stage. You have maybe 4 talking and 4 who are watching, and they can connect. But I hope that in 2 years, when we have a bit more, budget and things like this, then we can invite anyone who's interested. Obviously, people who would be able to give a talk wouldn't necessarily be people who haven't done analog space mission, because it's still the main focus. And right now we're trying to build a community, not making it a super famous event. We're trying to make it a known event for this. But we'll see what happens in 2 years, And the reason why I'm putting everything on YouTube free of charge is because I think lots of people are interested in them and they can't necessarily travel. And if you have in the same channel all the same, all talks, then you can see, okay, oh yeah, I wanted to know what is high seas, or what's a hormone mass, or what's AstroCapsule, and you have literally the video right next to each other, and you can compare. And yeah, if my camera doesn't crash in the middle, I hope it doesn't.
It won't. And you can also tell the dates. I think it's happening in the month of March, right?
April, so 2nd to 3rd of April.
Okay.
Yeah, so the name is Chasm. I'm putting in the chat, 2nd or 3rd of April. And it's I'm organizing it with the Mars Society UK. So it's like on the website if you need to look at it. And yeah, if any one of you is in Cambridge on that weekend and you want to come and have a look on the afternoon, and maybe we won't have all the place filled, so if you want to have a look, it should be probably fine. It's just I can't sell the tickets right now to everyone, because obviously we have to prioritize people who are going to give the talks. But really, if you're around, just come by in the afternoon. It'd be really cool to have you. So
if not this year, maybe after 2 years we can participate, right?
Yeah, maybe in 2 years you're gonna be like an analog astronaut from like 4 different missions, and you're gonna be like, yeah, I can give a talk for this, and this.
I very much look forward to that. I'll try to do that.
Yes, please.
Yeah. So we talked about the conference as well. So what not? I would like to put it this way: which astronauts are your inspiration? Like who are they that keep you driven throughout this, and you're continuously working to become like an astronaut? So we were excited to know that story.
I can show you. I have a YouTube video that I made exactly on this. So if I want to self-promote, I can just send you the link. But so there's a few astronauts that really inspire me. Obviously, every astronaut is an inspiration. I think it really does. Even those who are maybe in a bad mood, or they're still an inspiration, because it's they go where nobody else goes, and it's what I love about the job as an astronaut is that you give everything. You give your mind, you give your health, you give your time, you sacrifice sometimes relationships and stuff like this for the greater good, for the advancement of humanity. and it's amazing, you know, and you still get to see one of the most beautiful views in the world. So anyway, the inspiration, but one of the biggest inspiration was, for example, Claude Nicollier, who's the Swiss astronaut. And the reason he's so inspiring is he's extremely modest when he's smart, dedicated, passionate, communicative, can speak several languages, was a test pilot, was an astronaut, was an astrophysicist, like literally. And you can take a train next to him, or he's like, oh, I hope you guys have a good, we'll be fine. You know, he's down to earth, although he was in space, and he's supportive of any space initiative. He's there when you need him, and it's really, really impressive. And like every time you listen to him, you want to go to space right away, even if you're not an astronaut fan. You're like, okay, yeah, no, we're going to space. It's fine. So I can send you some talks from him, but he's really lovely. And obviously because he's Swiss, you know, we hear from him a lot. Or when I was studying my undergrad in Switzerland, he was giving talks all the time. So every time I was like, I'm going there, I'm going to go listen to him. So yeah, him. But obviously most people get, like, you know, impressed by Yuri Gagarin because he was the first man in space. But for me, the one person that will always have a special place is Alexei Leonov. And he was the first man to do an extravehicular activity. And not only, I saw him like 5 years ago. It was called the Moon Race event. And there was Buzz Aldrin and Alexei Leonov. So Buzz Aldrin was second man on the moon, and Alexei Leonov was, you know, then this man who went in EVA. And it was funny because Buzz Aldrin was wearing like 20 watches and badges, and he had a rock band, you know, like, and Alexei Leonov was in a black suit, black tie, and he had the Red Army Corps. And he was so humble towards Yuri Gagarin. He was saying, oh, he opened the door to space, and he made 3,000 people stand up to the, you know, Soviet anthem to, you know, commemorate Yuri Gagarin. Then I think he's crazy. He's the most brave person I've ever heard of, because when Alexei Leonov went outside of a spacecraft, his spacesuit inflated, okay? And inflated so much, he couldn't get back in the spacecraft. So he was like, okay, what am I going to do? If I tell Mission Control Center, they're going to lose their shit. They're going to be like, oh my God, panic, and I'm going to die. But if I rip a bit of my spacesuit, I make a hole in it, it deflates, I have, say, about 30 seconds to get back in the spacecraft, or I will die, but I should be able to get back in. And that's what he did. So you are in your first EVA, you're already one of the bravest of the bravest, and you make this massive decision, first not to tell anyone, and just do the only thing you can do. You stay calm, and you make the only thing you can do to try to make it back alive. And he made it back, you know? So for me, it was like, wow. And one of the third person, I've got obviously more, but is Scott Kelly. He's one of the twin astronauts, okay? And the reason I really admire him is not for all the things he did, is when I read his book on his life, so it's called Endurance. It's a really amazing book. I had just read Chris Hadfield's book, and Chris Hadfield, he's like perfect, you know, he's the perfect astronaut. Like there's not that many things wrong with him. And Scott Kelly, he tells you, oh, well, you know, in school I was really not paying attention. I didn't have good grades, and I was a bit lost. And you know, you can see he's this confused young adult who doesn't know what to do. And then he read the right stuff, the book, and he decided he wanted to be a pilot and then become probably an astronaut. And then he had this focus, and he was like, yeah, I want to be this. I'm going to train for this. So you have this lost kid who goes from this lost idea to this focus and this hope. And then he goes to the school, the military school, and they'll tell you, look, you don't have the grades. You're not going to do this. And in the book, he describes he walked out of there and he had tears in his eyes, and his parents were maybe not guiding him in the right direction. And he was just lost. And, you feel this, you feel this dream that's been ripped off. But then you think, hey, this guy's an astronaut. This guy just did 1 year in space to compare with his twin. And that was really inspiring. And the way that even astronauts are not perfect. They also fail. They also had, mishaps, and that's fine. And Scott Kelly was amazing also when you read his book. He's like, he can be really grouchy. Like, he's like, oh my God, the CO2 level is high. I've got a headache again. Like, he's not, this stereotype perfect person. And that for me is really inspiring. Not because I want to be grouchy, but because, yeah, it makes him human, and he's still a superhuman in the way that he accomplished all those things. So yeah, these are the main thing. But obviously, so many of them are inspiring.
Wow, like hearing about the incident, like there was with the incident with the spacesuit, it's terrifying to even imagine it. And taking decision at that very moment is really brave, and that was really inspiring for me to hear the story. Thank you for sharing it. And as you talked about literature also plays a major role in shaping things, I would say. And with this, we have recommendation of a book from Karine, and the book is Two Sides of the Moon by Alex Leonov. Sorry if I don't pronounce it right, and David Scott. Guys, you can check that out because it's a recommendation from Karine. I'm very sure you'll enjoy it.
Sure. I'll have a look. I can also send you. So in my video, sorry for the shaming self promotion, but in my video I put the link so you guys can just go to the link themselves of the thing. And while I'm sending videos from my LinkedIn, my YouTube channel, I'll send you the link also for the base visit. Sorry again, it's in French, but you should at least have a look at how it looks like, and then you don't need to listen to my awful voice again because you had already 2 hours of it this week.
We have another very important question from Sip Shankar, and he says, how do you cope up with analog projects and your doctoral research simultaneously?
So I'm really lucky in the way that PhDs can be very flexible. It depends on what kind of research you do. But basically, like, you decide when you work and how. So if I want to work on a Sunday, like for example, after this talk, I'm going to be on my computer and I'm going to be doing simulation. Okay. So I can work on a Sunday, I can work on a Saturday, I can work every evening if I want to. But I am my own kind of leader. Obviously, I have a bit of influence from my supervisor, the people who pay for my work, but mainly it's my own decision. So when I was doing the analog space missions, I knew I had to spend 10 hours per week working on it. And the way I cope with it is by reducing the amount of hours I had to spend on it to maybe 5 by being very efficient. So as soon as I would get a task, instead of waiting and thinking all the time while doing my PhD, I have to do this. If I could, I would interrupt. I would do the task, write the report, make sure it was a good report, but not necessarily spend too much time on it, and then send it right away. And that really helped me because I could see lots of my analog astronauts, they had problems with deadlines because they would receive the instruction and they wouldn't do it right away, either because they didn't have a choice or didn't want to, and then they would forget, and then you had to chase them. So the flexibility of my PhD actually is what allowed me to do this on the side. So if you have a flexible work, it works. But if you don't, then you have either to have an automated system, or you have to be extremely disciplined to tell yourself, well, I have this task to do, I have this to do, this to do. And yeah, it's like be extremely proactive, be extremely organized. And the other thing that really helped me is I loved contributing to it. So every time there was something new, like especially at the beginning of AstroCapsule, it was a very, very brand new mission. Like we were the first crew, So every time I had an idea, I was telling them, oh, actually, could we do this? Could we do this workshop? Maybe we need this training. Maybe we did this. So I was implicated enough in the mission that there were no big surprises or no moments where I had to work extra because I was late for something. But yeah, no, the big problem was COVID. COVID delayed the mission massively. So the mission took more time than planned. But for me, it was worth doing because I probably learned more from AstroCapsule than I will learn from my PhD. I mean, I'm learning a lot from my PhD, but it's very different. The experience I got as an analog astronaut is not something you can get kind of anywhere else. Like the same feeling, the crew feeling, I've learned more psychology, team management, organization, public speaking even than I would learn in 10 years of PhD. And I've got only 3 years of PhD. So.
There's another question. He says, could you mention the most anticipated projects to come up in the analog missions?
So I'm not sure what you mean by anticipated.
Anticipated, yeah. If you can clarify, Manoj, a bit on that, maybe we can take the question again. We'll move on with the next. And if you want to unmute and ask, you're free to do that.
Yeah, thank you. I didn't want to interrupt in between. So, hi, Eleanor. So, as you know, India is coming up with an first human mission, that is Gaganyaan. So, after that, most of them would be interested in these kind of analog missions. But I wanted to know how to get affiliated and recognized if you want to start up this chapter in an Indian or an Asia Pacific region.
So I'm not based at all in Asia or India, so I would have to look for links for maybe people I know. I mean, obviously, I think Hushira would be the best like a starting point because obviously she has more link in aerospace in India. But the main thing would be also for you to think clearly, what do you want and how big? Like, do you want, again, like AstroCapsule student level, or do you want something that would be used by a space agency in India to then be used by specific astronauts, or do you want something in between, accessible to all citizens, but probably people who have a bit more money and will self-fund? So already think about this when you start it, and then think, to whom can you be associated with? Because if you do, for example, your own research, then you can maybe talk to universities, say, oh, do you have any students who want to work with us, or any researchers that want to work in our team? But if you only want to focus on training of astronauts, then maybe universities don't care about the research you do, because maybe you're going to focus on the spacesuits, or you're going to focus on, some diving and things like this. So always think, what is going to be your space mission like? Or do you want to offer the whole range? And then start with one kind of range. Or you could say, well, I could first talk to the government and explain how it could be useful. And if they say no, then you go to the next step. I don't think there's any right or wrong way to do it, but then I did not found one myself. So, I could put you in touch with other people who founded their own. So, for example, Professor Bernard Foin, he was working for ESA, who still is, and he's helping with Euromoonmars, obviously. He could be one person that could maybe guide you, give you advice. So, like, I can ask him if he'd agree to, chat about this. But yeah, I don't think there's any wrong or right way. You just have to define and just get going, contact as many people as you can, and maybe it will take time at the beginning to get the right people. But for example, if you contact AstroCapsule and then you contact other companies, that are in direct relation with India and aerospace, I'm sure lots of them would be really, really motivated. And then they could put you maybe in touch with the right people from the government. Professors usually in universities do have quite a bit of influence. So I would also go that way. So have a look at the universities that are the most prominent in space research, either astronomy, robotics for space exploration, astrobiology, because there you will have some space nerds and you probably have the right people who've got the contacts. So it's really about this. It's kind of getting into there and getting the right contacts that can then help you to get it done. And again, I said on Friday, happy to help if I can. I mean, as I said, I don't have many more contacts in space in India, but if I ever do, I will send you all my help, really.
Okay. So one more thing, I wanted to know that how the mission duration is determined for every analog mission. So you said you went for 3 days or 7 days or something like that, but I did come across one of the mission which NASA is planning, that is the Mars Dune Alpha. They are planning for a mission of 1 year in an isolation in an enclosed chamber. So how do they determine these kind of time durations, and what all things are considered while doing this?
So again, it depends on the kind of mission. It depends on what you're trying to see. So for example, obviously the 1 year mission is because we're trying possibly to simulate a voyage to Mars and back. Okay. So this, we want to see mainly the psychological aspects and what kind of inventory you need, like how much food do you need, how many support systems do you need. For AstroCapsule, we were student-led, so we have a limit in budget. we have a limit on people availability. As said, some people had just finished their exams and were going to do an internship like 2 weeks later. Because of my PhD, I had to just take holidays to do that, like it was my holidays. It wasn't included in this. So every time I took free, I had to then compensate, so this is the kind of thing you have to see. It's like, if the space mission is organized for professionals, then they have way more time. If it's organized by students, then they don't. And it depends also if you're trying to just test spacesuits. I mean, spacesuits you can test in like 2 days, 3 days, maybe, unless you want to test where. But usually that's not about how many days the mission is. It's just how many EVAs you do. And you can test the psychology. And the psychology, I mean, if I simulate 24 hours, it's not going to be the same as a year, right? Although I know some people who spend 40 days in a cave without a clock, and time seemed to pass like slower. So, you could probably accelerate the thing by putting them in the cave. But the fact is, it's like, that's why there's so many different durations, is you don't always look at the same things. You don't look at the same consequences, and you don't have the same tests. So yeah, for example, for you, maybe you just want to see if you enjoy it or if you will kill someone or not. So a 7-day mission is enough for that. If you go straight away for the 1-year mission, you might really not enjoy it, but because maybe you're not prepared for it. So it's sometimes nice to start with a week and then do a month and then do a year,
Okay. So I wanted to know that these analog habitats, they are at a particular locations, like depicting the similar conditions of the extraterrestrial or the moon conditions. So I wanted to know, what is the difference between making this in an enclosed habitat or an open habitat? So how would that actually differ in an analog mission?
So basically, if you don't have an enclosed habitat, you don't simulate the danger of having no atmosphere. Okay, so it's nice to do it in the desert and everything, but if you are on Mars, on the moon, unless we manage to terraform them, we won't have the right atmosphere. So we will always have the spacesuits on Earth, and we will always have to some extent a closed habitat. But then the difference is obviously if you see the views of for example, the desert, and it looks like Mars, then probably you feel a bit more stranded and a bit more like, like if you feel it's beautiful, so I guess psychologically it's nicer, maybe a bit scarier, but nicer. But you have the problem of extraterrestrial. So for example, MDRS in Utah, sometimes they have tourists that come and look at the base. So when you're doing a mission, you try not to see any human, and then some person is walking their dog around the base, then you break this simulation. So that's the problem, okay? And on Earth we have, unless you really like in the Arctic Circle, where nobody's going to randomly knock on your door except a polar bear, then, you have this problem of people being around, which you don't have when you are in a sealed habitat. So for example, for us, I was thinking, it's a bit sad. Like, it's true that, we don't have the view of the desert, or we're not in the, we're not seeing the cold or whatever, but actually the base itself was so beautiful. It was all this granite, it was all rocks around, and it did make it special already, because it's not a habitat where we live usually, unless you work in this place, but it's fascinating on its own. So that was lovely, because we had the compromise of a sealed environment because it was underground, but without having completely artificial environment. That it wasn't just metal or plastic walls. It was rock, rock, as we say in my team. I hope that makes sense. I hope I answered your question.
Yeah, it did. One last question from my side. So you did mention about the communication delay which is happening in the analog habitat and the mission center. So how is this actually depicted? So how do we actually simulate it, and do we have some timer or something like that, like somebody from the mission center is contacting and we have a timer which is running, then after 3 minutes we are communicating with them or something? We are actually depicting the communication gap that is being there in between the Mars and the moon missions or something like that.
So I can't answer this because we did not have it for our mission. So the mission who had it was Austrian Space Forum mission that happened in October, November. So they would be able to answer to you. I don't know exactly how they did it. I would expect that the message was transferred right away, and it was blocked, by the software and released after 23 minutes of timer. So that's how I would do it, and I would expect the same of happening. We were using TeamSpeak on computers, which is usually for gaming, and so you just buy Wi-Fi connection. I don't know if you can have a timer delay on it. So yeah, sadly, I can't answer this question because I wasn't part of the crew. But in 2 months after Chasm, I probably will be. I can ask them this question for you if you want.
Sure. Thank you so much, Eleanor. That gave me a lot of insights, and it would surely help me someday in near future. Thank you so much.
I hope so, and thanks for the questions.
So we are quite nearing to a time limit. So I'll take the last two questions from my side. So very first is there was this moon race, and now I can see there's this bidding competition for Mars, and there are private companies as well coming up with various missions, and then this Axiom is coming up with their ISS like structure, and so with all this, the space tourism and everything, how do you think space is becoming more accessible, and do you also think that we are kind of polluting it more than we need to?
So finally, if you had talked to me about going to Mars 5 years ago, I would have said no. Because I thought, well, first, we need to take care of our planet before we go there. And secondly, we might contaminate any life that's in there. For the moment, we haven't found life on Mars, but it doesn't mean it's not there. And we might do the same as we did, when we go to South America and we bring germs and we kill the local population, not just with weapons, but actually biological, germs. And which is why when you send robots on Mars, you decontaminate them. So there's a certain level of bacteria per square centimeters allowed, okay, to prevent this from happening. And when we're going to go there and do settlements, how are we going to do this, right? There will be some cross-contamination. So I was personally against, but then I realized it's going to happen whether I want it or not. We're going to get there, whether I'm not going to be the one with my flag saying, no, let's not go right away. So the best I can do as an individual is to try and create this strong community on Earth that will try to prevent us from doing any stupid things on Mars, such as having a war on Mars or doing segregation on Mars. Because that's the thing, like if you allow people to go on Mars and make holes wherever they want, regardless of other countries, regardless of any life on Earth, you can have big consequences. And I think this is like something that we need to work on. So I think that's why space law is also very important to me, because we need to work quickly to really work on this and prevent anything from happening to Mars. So we're going to go there, but we need to go it there the right way. And I think space is more accessible, as in we sent some people, like we sent one woman who was 82 years old, and she was in the first astronaut selection for the Apollo mission. And that was really cool, because you think, well, the only reason she didn't go to space before was because she was a woman, and then she gets to go there. Okay, it's 15 minutes and yada, yada, yada. I'm not going to say everything I think about it, but it's still cool, but it's still billionaires and still a few lucky people. And to me, the space is still something we need to respect. When I agree to go there as an astronaut, if I can, because everything I will do in space will be given back to Earth and humanity. When you develop habitats that survive in extreme environments, when you develop food, when you test biological, drugs, like when you test osteoporosis, it's used. Everything we do is used, so you take and you give back. But when you go there 15 minutes because it's a nice view, yeah, I'm happy for you, but Jesus Christ, like, can we can we give the same for like climate change exploration, and stuff like this? So yeah, so there's both of them. I think space exploration has helped massively for climate change monitoring, climate change observation. Lots of astronauts, they want to protect the Earth even more when they go to space, because it's like, okay, guys, it's really fragile and we need to do something. But some other people don't necessarily have this consideration. But we have to go with it. Like as much as we don't want to, there will be this, and it's getting more accessible. I mean, like more countries are getting there. And I think this is where space law could also be useful, is if we have kind of control on what's happening. For example, I don't understand how Elon Musk doesn't have necessarily some laws saying, no, you can't send 400 satellites like this. Why is this not being controlled? We have so many satellites around the Earth. We need to get rid of some of them. We need to, remove them before we can say, oh, yeah, sure, fine, go ahead. Yeah, no, these days, yeah, there's no more night sky, but it's fine, Obviously, I think this is where we can get lower, and this is where you can also tell other countries who have a bit less income, actually, you could partner up with those other countries, and according to this law, we will give you a fund so that you can have your own GPS system, because some countries don't necessarily have a really functioning GPS system or communication system, but also we can help you do also space explorations that really make it accessible to all. So yeah, it's in progress, I think. That will be my main answer.
Yeah, very true. And talking about polluting the planets, like there's this popular idea of planetary parks, which is like we are trying to create or preservation areas on Mars and Moon so that we don't contaminate them by like our exploration, or if we are planning to land and launch through the chemicals that we'll be using. So that is one of the popular idea that we are working on in the recent times. And also Karim says that we've already lost some tardigrades on the Moon. I'm sure. Yeah.
and they survive pretty well, so like they're probably
Yes.
gonna be alive in a million years. We're gonna be like, how did you get there? Like, why
Yeah.
did I put you in Andromeda and Milky Way?
It would be interesting to go back and sample them and study them to see how they have responded to the radiation that's been on the moon, right? That could be
They
one.
alien pets now. They've been adopted by another civilization.
Wow. And so, okay, so last question for today. So what would you say to the young people who are out there in the industry and trying to establish them into the space sector? So what would be your message for them?
Keep dreaming, not in the bad way, in the way that keep hoping and loving what you do, but also don't be scared of reaching out. There's lots of mentorship programs. There's lots of people who love what they do. Like for me on LinkedIn, like the last month, I've discovered so many people that were just amazing. And you talk with them, and then you're like, oh yeah, let's do this together. Or let's it's not complicated. And if they don't answer, they don't answer. It's fine. But there's so many people who love this. Like I met amazing people like Richira. We met like in Habitat Matre. Why? Because 2 months ago, I thought, well, I've heard of this. Why shouldn't I do it? And I did it. Literally, if you can, just try, and maybe you'll meet amazing people and you will learn. And basically, try every opportunity that you find. Okay, try it out, and don't be afraid. Okay, especially if you want to be an astronaut. Okay, you can't afford to really be afraid. You have to try and again until you succeed, and someday you will die, and enjoy every step of that path to the stars. Even if we don't get to space per se, we'll get to exceptional places, and we get to meet exceptional people like all of you guys today. Like all of this is the greatest gift that we have in the space industry. So really keep it alive by always trying for more.
Yes, and also I would add to it, have fun whatever you're doing in it, right? Don't miss on fun.
Exactly.
So with this, I think I've covered all of my questions. I'll give another 1 minute. If anyone else has any questions, can type it or feel free to unmute and ask. Anyone?
Yeah, hi.
Hello.
Hi.
Yeah, my question is that sometimes we have designed that particular space mission or even some suppose satellite for the specific time period like 2 year, 3 year. But we hear that it will work after that also, after 2 year or 3 year also. It's continue working. Can you explain about this? How it happened?
I'm
So,
not
so
sure
I
what you.
think,
Yeah. Sorry, go.
yeah. So I think he's trying to ask you the question. Like we define this particular mission period. Like this mission will go on for like 2 to 3 years. But sometimes it does happen, and mostly in the case of the Mars rovers, it has happened that they have extended the mission. So how does that happen? That is
Yeah,
his
how to
question.
increase the
So,
lifespan?
Yeah.
basically, so I don't know what your background is, but if you're an engineer and you've worked with, well, norms and things like this, all material life and component life is in a certain brackets. And then we use statistic to say, well, it's very likely it won't last that much longer. But there will always be some occurrences where your material life is actually longer, okay? Especially in the space industry, we make massive like your material life would be this normally, but we will say it's this only because it's safer, okay? So this is just so that we are sure it's going to work. Well, 99.99% sure it's going to work for this 2 3 years. But the actual material could probably live like 20, 30, 40 years more, right? So we're just making our technology extremely redundant and extremely robust because it costs a lot and we don't want it to fail. And sometimes it does, but sometimes it doesn't, and it exceeds its life. So I think that's the main thing. And sometimes you think, well, it's extreme environment, there might be a sandstorm or there might be something happening, and they don't happen. And these would be the main life-threatening things for those components or for the robots, etc. And this is why they just last longer. And if we have also data that's exceptional, you will extend the measurement time. And thirdly, something that's not material or just data related, it's also budget related. So sometimes you have a project that is funded for 2 3 years and then it's cut, and then sometimes we have good results and you manage to release more budget for it, and then you have more people available to take care of it. So these are all the aspects of space missions that we cannot forget about. If you don't have people working on it, then you don't have data. Sometimes that's as easy as this, like we could have kept on going to the moon, but we didn't have enough, budget allocated for it, or we didn't have enough interest any more from the population to do it. It's not that we didn't have the technology. It's not that we didn't have, and we were really missing any crucial thing scientific. We just didn't have the budget anymore. And on the reverse, you can have massive interest, and then suddenly everybody wants to see a robot singing "Happy Birthday" to me on his birthday on Mars, So yeah, so I hope that answers your question.
Yeah, thank you.
You're welcome.
So I would also request all the participants, if you have no more questions, just turn on your camera so we can take a good photo. So we can remember we had this great conversation with Eleanor. I'll give you 30 seconds, just turn on your camera so we can just have a nice click. Not a compulsion, but we would love to see everyone who's attending. Yeah, we can see faces.
The poor people who wanted to be cozy in a pajama on a Sunday afternoon and you make them turn on the cameras. That's really mean, really. Okay, let me know and I'll just do that.
Yeah, Prasad, just do the countdown when you're clicking it, okay? Yeah.
Are you taking a picture or am I taking a picture? Let me know.
My colleague Prasad is taking the picture.
Okay, perfect. Otherwise I can do it. I want that picture too. Okay.
So,
let me know.
Most of them. So we'll start. This is 5, 4, 3, 2, and 1. That's it. Thank
nice.
you. Thank you.
So it was amazing talking with you, Eleanor. And this conversation today we had was best. I think most of you all must have benefited from this. And so with this, we have reached the end of a 3-day webinar series on the topic of space analog mission. And if any of you all have missed a particular day or had some network issues, we'll be posting these recordings on a YouTube channel, so you can revisit them and watch there as well. So with this, I thank everyone who has attended, and again, I thank Eleanor for accepting our invitation, coming here, talking with us, and we wish her all the best with all her future dreams. Keep working, girl. You're doing it.
Thank you so much for the invitation and the attention. And yeah, you guys, I wish you the best of space. And keep loving what you're doing. Amazing. Congratulations to AstroCapsule for the wonderful job that you do. Really. It's amazing.
Thank you. Thank you. So yes, with this we end, and I'll stop the recording. If you guys
Thank you, Eleanor, for inspiration.
Thank you, Pablo, for contributing too. It's lovely. Take care, everyone.
Bye-bye.